Welcome once again to my YouTube channel, and I want us to discuss example 11 of Pure Mathematics 3, and in topic 8, the very last example in this topic of integration. And I must tell you that this example is quite an important one, so it is important that you follow closely. We are told, given that the integral from 0 to theta of 5 tan x sec 4x with respect to x is given by 15 out of 4. Where theta is greater than 0 and less and less than pi over 2. Now the question is, find theta, the exact value of theta. Find the exact value of theta. And I want us to just get to this question, and we must know that we have the sec raised to power 4 of x, and to me that is now the function of x, that is the fx, where n is 4. And if we just literally apply what we have learned in the example 10, and I want us to just be keen here, we are going to say, or rather we are supposed to say, y is equals to sec 5 of x. Please remember, this is not going to work for us, but I just want to teach this to show how we are likely to make mistakes if we do not foresee a problem here, because the derivative of sec x itself is tan x sec x. And we may go back to page 1. If y is sec x, dy dx is sec x tan x. So in its derivative, there is the aspect of sec x. So if we take literally sec 5x, just because you are told try y is equals to fx with an increased power, let's see what we get here. Dy dx is going to give us 5 sec 4x times, that is the whole aspect. Now the chain rule applies here, and the derivative of sec x is itself sec x tan x. So at the end of the day, you're going to have 5 sec 5x tan x, and this is not in line with what we need. You remember, you look at this, the power is increased by 1, and we need the power that is 4. We have power 5. The reason why we have made this mistake is because we have literally taken y to be the sec x raised to power 5, just because we have been introduced to the same kind of approach in the previous example, having forgotten that part of the derivative of sec x has sec x itself. So this was wrong. This approach was wrong because it doesn't give us what we have. It's giving us something which has power 5, and we need power 4. So what are we going to take y to be? So cleverly, we must take that y is sec 4x. We have to reduce that power now, such that dy dx is 4 sec power 3 of x times sec x tan x. And this one now gives us 4 sec to power 4 of x, because of these 3 and this 1, tan x. And look what we have. We have 4 sec to power 4 of x times tan x, which is agreeing so much, only the constant we need to adjust just a little bit. That means what? This is 4 times, 4 over 5 times. This is 4 over 5 times what we needed or we expected. So what do? We have to divide by 4 over 5. That means if we divide by 4 over 5, then it's like multiplying by 5 over 4. And that is just like it. So 5 over 4 multiplied by 4 sec 4x tan x is by itself, this 4 and this 4 go away, so it's 5 sec 4x tan x, and that is what we wanted, that is what we expected. That means our integral is this now constant we applied in front of sec 4x, which we suspected to be our function, is going to be 5 over 4 sec raised to the power 4 of x. And of course we have limits 0 theta. Now at that point we just have to apply the limits and assume this is now what is equals to 15 out of 4. The only thing we need to do is just now to apply the limits. And because we have a perfect integral or a perfect integral or terminating integral, we don't have the constant now because we have limits. So it becomes 5 over 4 sec raised to the power 4 of theta minus 5 over 4 sec raised to the power 4 of 0. But of course we know sec 0 is 1 because sec is 1 over cos. So we have to remember that the cosine the cosine of 0 is it's 1. So 1 over 1 is 1. So we are having an expression that looks like 4 sec power 4 of theta minus 5 over 4 times 1, which is 1, which is 15 out of 4. And it goes without saying, we just now collect the like terms, and we have 5 over 4 sec 4 theta to be equals to 15 over 4 plus 5 over 4, which is 20 over 4. And yes, this follows that we multiply everything by 4 over 5 times 4, so 4 over 5, so these cancel out, and we're going to have sec 4 theta is 20 over 4 times 4 over 5, which is a 4. By itself is a 4. So we are having something that looks like sec 4 theta is equals to 4. This is to power 4. I wish it was squared, because if it was squared, then we would have just gotten the square root. But we can still follow that root so that we can understand. The root of that is the root of that, which is the sec 2 theta is 2. Of course, plus or minus 2. Plus or minus 2. And then again, directly, another root and another root. So we can easily say that the sec of theta is plus or minus the root of 2. Plus or minus the root of 2. But we have understood that the sec of theta is 1 over cosine. What does that tell us? We need now to say, since sec theta is 1 over cosine, then the cosine of theta is plus or minus 1 over root 2. The cosine of theta is just plus or 1 minus 2. And how do we talk about this? If we have an angle which is 1 over root 2, because this could be the theta itself, 1 over root 2. So root 2 squared is 2, 2 minus 1 is 1, so root 1 is 1, so that is another 1. according to trigonometric ratios. Meaning that if this is now an isosceles triangle, a right angle isosceles triangle, and obviously this is 45 degrees, which is pi over 4. Also, this is pi over 4. So, meaning that theta is, let's talk about minus pi over 4 because of this negative. We can talk about theta as pi over 4. And if we apply all science teachers complaining, this is pi over 4, this is pi over 4, this is pi over 4, and this is pi over 4. Remember, this is pi minus pi over 4, which could be 3 pi over 4. But look at the range. Look at the range. The range, we are told that theta is greater than 0 but less than pi over 2. So we do not need to go further than that, because we have so many assignable values of theta. We are not expected to go further than that. So theta is not, theta cannot be negative, so that one is out. And theta cannot be greater than pi over 2, so that one is out. So the two outside are outside our range. So the only perfect value of theta in this particular question is pi over 4. And again, please follow that question very closely. It is quite important that you realize how we've solved it. But the most important part was what I explained in the first place, and what I rejected, and I gave you reasons to reject that. So again, visit my YouTube channel, subscribe and share widely, and let us see. All right.